This is Shane Picard with another geometry lesson, and in this lesson we'll be talking about simplest radical form. Simplest radical form is actually an algebra topic, but it's something that comes up regularly in geometry, and so it's worth reviewing. A question that frequently arises is this: should I leave the answer in radical form? The first way of answering this is simply to read the question you're answering. So if you're taking a test or you're answering a question on a standardized test, and the question writer has directed you to either leave your answer in simplest radical form or round to some particular place value, then of course you have to follow the instructions. But short of that, just generally speaking, what's the answer to the question? Before we try to answer it, we have to ask, well, what are the options? What forms can my answer be in typically when I'm dealing with radicals? First is radical form. And radical form, of course, is where you're still dealing with a radical, and that includes the radical sign and also the value under the radical, which is called a radicand. That is called a radicand. The second option for forms of answers is standard form. So, for instance, if I have a number like square root of 9, I can leave that in radical form, or I can turn that into standard form. In this case, it would be 3. So there's radical form and there's standard form. When is the distinction worth noting? When is it really worth talking about the difference between radical form and standard form? The answer to the question is anytime the number is irrational. Remember some number sets that you've probably studied in the past. We have counting numbers. Those are numbers such as 1, 2, 3, 4. Sometimes we refer to those as natural numbers because those are the numbers we all naturally start with. There are whole numbers, which are the counting numbers, and 0. So we have 0, 1, 2, 3, so forth and so on. The counting numbers, we run into integers, which are the whole numbers and their opposites. So numbers such as -3, -2, -1, 0, 1, 2, 3. We get numbers which are called rational numbers. Rational numbers are any numbers that can be represented by a ratio of integers. So for instance, the number 1, of course, is a rational number because it can be written 1 over 1. The number 17 is rational because it can be written 17 over 1. The number 0.5 is a rational number because it can be written as 1/2, 1 over 2. The number 0.3 repeating is also a rational number because it can be written as 1 over 3. So there are quite a lot of rational numbers, but when we talk about all real numbers contain both rational numbers and something called irrational numbers. Well, what are irrational numbers? Irrational numbers are numbers that cannot be expressed as a ratio of integers. So numbers like pi, for instance. Pi cannot be expressed as a ratio of numbers because pi is a non-repeating decimal. Numbers like the square root of 2. If we were to ask the question, what is the square root of 2? The answer is 1.41421356237, and the number goes on and on. So it is a non-repeating decimal. So when we're talking about, in this context, about radical form, it's only when we have these irrational numbers that we really find a useful distinction between radical form and standard form. In other words, stated differently, if the number is ultimately a rational number, then we would simply express it as a rational number. We wouldn't leave it in radical form. Are there any advantages to radical form? Yes, there are. It's more precise. Radical form is always more precise than a rounded value. When an irrational number is rounded, precision is lost. So for instance, some people know pi to the 48th decimal, 3.1415, whatever it happens to be. And when we round off the ending of it, and we round it just to 3.14, the number is less precise than if we had more decimals. Ultimately, of course, you have to round an irrational number someplace if you want to write it out in standard form. There's no getting around that. So what do we do? If it's a number that does not need to be expressed in standard form, and it's a non-repeating decimal, that is, it's an irrational number, then we simply leave it in simplest radical form. That's the answer to the question. What are some circumstances in which we would need to have a number in standard form other than those circumstances where a teacher or a test administrator tells us to answer in a certain form? You can imagine walking into a hardware store and you're trying to buy rope. If you know that you need 2 times the square root of 5 feet of rope, that number is not really going to help very much. It'd be much more helpful to express that as a rounded decimal and then perhaps by just a little bit more. Same thing if you're trying to paint the wall and you know that the surface area of the wall is 216 times the square root of 3 square feet. That number also will not be very helpful if you're walking into the paint store to buy paint. You need a nice, typically you need a nice number in standard form with which to communicate the information you're trying to get across so you can buy the appropriate quantity. How do we work with radicals? Some simple things we should keep in mind is that you can multiply and divide numbers that are under the radical signs. For instance, let's simplify the following expression. Square root of 2 times the square root of 8. Because we can multiply these numbers under the radical signs, this is equal to the square root of 2 times 8, which of course is equal to the square root of 16, which is equal simply to 4. So we can simplify these expressions by multiplying underneath the radical signs. By the way, if you're wondering why that is, it's because a radical is inherently linked to multiplication. Remember, the square root radical asks the question, what number can be multiplied by itself to produce the radicand? So in this case, what number can be multiplied by itself to produce a 2? So it is a multiplication question, and therefore this idea of the associative property of multiplication certainly applies. Let's look at one other example. Square root of 27 divided by the square root of 3. That is equal to the square root of 27 divided by 3. And the square root of 27 divided by 3 is equal to the square root of 9, which of course is equal to simply 3. So we can do that as well. How do we get an expression, radical, into simplest radical form? There are 3 rules we need to keep in mind. First rule says that the number under the radical has no perfect square factors other than 1. So there are lots of numbers we can look at and say, hey, there are perfect square factors in there. For instance, if we have a number like the square root of 9, 9 is a perfect square. So the square root of 9 is not simplest radical form. So because that perfect square exists as a factor in the radicand, we need to get it out of there. In other words, we need to rewrite this as simply 3. Let's look at a slightly different example. Suppose we have the square root of 18. Well, 18 contains a factor of 9. So we need to rewrite that as a square root of 9 times 2. Well, just a few minutes ago, we remembered the fact that we can separate or combine or associate factors under the radical, which means this is equal to the square root of 9 times the square root of 2. Well, square root of 9, of course, is 3, so we have 3 square root of 2. Notice that our final radicand does not contain any perfect square factors. We've taken out the perfect square factors in the form of that 3. We've left behind anything that was not a perfect square. So we end up with 3 square root of 2. Let's look at one more example. Suppose we have the square root of 50. Well, 50, of course, is 25 times 2. So we need to remove that 25. We cannot leave that in the radicand and call it simplest radical form. We need to get it out of there. So the square root of 25 times 2 is the same as the square root of 25 times the square root of 2, which is equal to 5 times the square root of 2. And so that is our final answer there. That's simplest radical form. There are a couple tips for recognizing perfect square factors that may help you. The first one says that you may recognize multiples of 9 by adding all digits until you've reduced the sum to 1 digit. If 9 is a factor, the sum will be 9. Let's look at a few examples there. Suppose we have the number 18, and I'm wondering whether 18 is a multiple of 9. I just add the 1 plus the 8, and you'll notice I get 9. Look at a number like 162. We ask the question, is 162 a multiple of 9? Well, we add the 1 plus the 6 plus the 2, and we get 9. Therefore, 162 is a multiple of 9. And it doesn't matter how large the number is. Suppose we had a number like 927. 9 plus 2 plus 7 is equal to 18. And then we add 1 and 8, and that equals 9. That means 927 is a multiple of 9. So that's one very easy way to see if the number you're looking at is a multiple of 9. Certainly once you realize it's a multiple of 9, 9 is a perfect square, you need to pull the 9 out of there and get rid of it. So if we had something that was, for instance, the square root of 324. First question, is it a multiple of 9? Well, 3 plus 2 plus 4 equals 9. So it is a multiple of 9. So we need to factor that 9 out of there. And to do that, we would reach for a calculator. Square root of 324 is the square root of 9 times 36. 36, of course, is a multiple of 9. So that means we have 9 times 4. So now that we've broken this particular radicand open, you can see that it contains all perfect squares. So it ends up that this number is equal to 3 times 3 times 2, which is 18. So 324 is actually the product of 18 times 18. So that's one tip we can use. Let's look at another one. Some other obvious ones, perhaps. Multiples of 100 always end in 0, 0. So any radicand that ends in 0, 0 is a multiple of 100, and 100 is a perfect square. Multiples of 25 always end in 0, 0, 25, 5, 0, or 7, 5. So anytime we see a number ending with those two digits, we know that 25 is a factor there. 2 can easily be factored out of any even number. If the other resulting factor is also even, then a 4 is a factor of the original number. So for instance, if we were to take the number 88 and factor the 2 out, we end up with 2 times 44. Because 44 is an even number, we can be sure there's another factor of 2 in there, 22 times 2, and we can factor this perfect square 4 out as a 2 in front of the radical. It would end up looking like this, 2 square root of 22. So those are some tips that help us to find those factors a little bit easier. If all of that fails, then you begin to go through the list of remaining prime numbers, prime factors. So we've already talked about 2. You might divide the radicand by 3 to see what's inside there. 4, you don't need to. None of the even numbers are prime. Then you might go to 5, and then 7. We've already dealt with 9. Then go on to 11, 13, and so forth to see if the radicand can be factored out into different numbers. The second rule we need to be aware of when we're trying to write a radical in simplest radical form is that the number under the radical does not contain a fraction. So for instance, if we had a number like this, that number is not in simplest radical form by definition. How do we fix that problem? That's the easiest one to fix. We just rewrite it as a fraction or a ratio of two radicals. So there we go. Square root of 3/4 is the square root of 3 divided by the square root of 4. Of course, you can see here the square root of 4 is equal to 2. And so we end up with the square root of 3 over 2. Third rule is that a denominator does not contain a radical expression. So for instance, if we go back to the example of the square root of 3/4, that's equal to the square root of 3 over the square root of 4. You can see that in fixing a number 2 problem, we ended up with a problem under category 3 because we have a radical down in the denominator. We've already seen how we can fix it in this particular example, although it's not always that easy. Sometimes we have to take other steps in order to get rid of that radical. Let's take a look at that. Simplify the following expressions. Square root of 9 over 2. The first thing we need to do is deal with the category 2 problem, and we do that by rewriting the radical as the square root of 9 divided by the square root of 2. Pretty straightforward. You can see we have a category 1 problem right here because the radicand in the numerator contains a perfect square. So that becomes 3 over the square root of 2. And we still have a category 3 problem because we have a radical in the denominator. How do we fix that? Very simple. We multiply the expression by a number which is equal to 1 and contains the same denominator as the value that we're trying to work on. So we write square root of 2 in the denominator, square root of 2 in the numerator. Notice this ratio, square root of 2 over the square root of 2 is equal to 1. We can multiply anything in the world by the square root of 2 over the square root of 2 and won't change its value because in reality we're only multiplying by 1. So when we multiply 3 times the square root of 2, we end up with 3 times the square root of 2. And in the denominator, we end up with square root of 2 times the square root of 2, which you can probably see is equal to the square root of 2 times 2. And of course, the square root of 2 times 2 is equal to the square root of 4, which is equal to 2. And that was the whole point. So we end up with 3 times the square root of 2 divided by 2. That is simplest radical form. Let's look at one more example. Square root of 4 over 3. This is very similar to the problem we looked at a few moments ago, the square root of 3/4, but instead the 4 is in the numerator and the 3 in the denominator. So again, we'll rewrite this as the square root of 4 over the square root of 3. We can change the square root of 4 to 2, 2 over the square root of 3. Now we'll multiply by the square root of 3 over the square root of 3 to remove the radical from the denominator, and we end up with 2 square root of 3 over 3. That is how we express values in simplest radical form. That sums up the rules we need to know to write in simplest radical form. Make sure you work through some review problems. If you have any questions, as always, send me an email.